Ladies and gentlemen,
welcome to CERN.
And indeed, welcome to CERN, the European Organization for Nuclear Research in Geneva. Welcome to the CERN Control Center. This is a view of the LHC underground tunnel. The LHC is the protagonist today. It's poised for another of its world records. We are trying to take the energy of the LHC to 7 tera electron volt to get collisions at 7 tera electron volt. This is the first attempt in history. Today, March the 30th, 2010. We've tried to reach the highest energy yet achieved in a particle accelerator. This is going to happen in around 3 hours or so, and hopefully it's going to mark the start of the LHC research program and a new era into the history of particle physics.
Good morning. Soon we should be ready after ramping at 3.5 TeV for collision today. I think everybody is anxious to go down and look for the ramp and then for setting the beam in collision. Thank you.
That comparison tells us a lot about the complexity of this kind of operations.
To get them to go on axis, basically, to get the beam position to zero. Yeah, these kind of energies and what we're doing, it's something of the order of 100 microns.
So, okay, we're both beams at 3.5 TeV, and we've just collapsed the separation bumps and brought the beams into collision at inside the 4 experiments. So, at the moment we have collisions, but the experiments aren't turned on fully at the moment. So the next stage is to bring the collimators into place, and then we can change mode to stable beams, and then the experiments can switch on their detectors fully and start taking data.
And this is Jürgen Schuhkraft, the spokesperson of the ALICE collaboration.
Collisions have arrived about 20 minutes ago in ALICE as well. First we had only a few detectors on because there were not yet stable beams declared. And so we had to wait a little bit. People got nervous, people got anxious. But once the stable beam flag was cleared, we could start all the other detectors, ramp up the high voltages. And then about 7 minutes ago or so, the first event popped up in the counting room, greeted with a lot of cheers and some champagne, which we are still drinking. And now, of course, we are collecting the data and checking that everything works well, but it looks very good. So we are collecting data at a quite good pace. The beams, we looked at it, they are nicely centered. So for us, this looks fine. Congratulations to the machine. Thank you for having given us some beam a little bit later than we actually thought. We are here since quite early this morning, but better later than nothing, and this beam is really great.
The Atlas collaboration, the scene events, we can see them on the screen. This is physics in the making.
So good afternoon from the Atlas control room. We have observed first collisions, beautiful events with a lot of tracks. So the beam collide perfectly, and the detector is working well. So it's a big emotion, and to see all these nice events popping out of our detector, it's the beginning of really a new era of great physics exploration. So we are all so proud and so happy, and we are sharing this with everybody in the Atlas collaboration all over the world.
This is the CMS control room also a couple of minutes ago, also recovering. This is a recording from a few minutes ago, CMS seeing the first collisions inside their detectors at 7 tera electron volt. A few minutes ago, the person with the mobile phone seen from the back is the spokesperson, Guido Tonelli, and this is the CMS collaboration. Guido Tonelli, we've seen you clapping your hands, surrounded by happy physicists from the CMS collaboration. It was a historical, but especially a happy moment for you.
Yeah, hi Paola. First of all, you can see here from the faces and the brilliant eyes of the people that we have spent many days and many months of preparation for this moment. But basically, at the end, we are here And we were expecting, to be really frank, just a few events, 1 per second or so, and we were really surprised to see rates at the level of 100 hertz. That means 100 events per second. And event display were showing not only minimum bias event, but also something that could be immediately interesting. So we really are starting physics, and this is really the first time in which we enter a new territory. Exploring 7 TeV will be a fantastic adventure. We are just at the beginning. Clearly, we have to do a lot of work. We have to understand our detector, to understand physics in this new region of energy. But if we are lucky, within a few months, we'll be able to really start a major adventure in modern physics. Then you see that there is a movie. I don't know if you can see. There are protons coming. This is a real event. These are the hits in the tracker, and these are the release of the energy in our real. It's not a simulation.
Yes, it was a great moment of excitement here when they moved the beam into collisions, and immediately we had an increase in the trigger rate, and then they made a small adjustment due to the orbit correction that they had measured during the night, and we moved up to 60 events per second, which is exactly what we would expect from the colliding beam. So it's really a great achievement. Now we are here in LHCb. We are trying to move in the Velo, the vertex locator, which is this very delicate silicon detector, which is in the very close to the beam, and we have to move it in very carefully because, of course, if the beam is hitting it, it could be damaged. So it's now being moved closer than it has ever been from the beam, and we do that step by step, but we reconstruct events, and everything is working as expected.
Which counts in thousands of people, particularly young people, working very hard to achieve.
Okay, so we have finally got the beams into collision at 3.5 TeV per beam. I think we're all very emotional, very happy. It's a great time for us, and this is the first real important milestone that we have for starting to do discovery physics in LHC. It's taken us 3 attempts this morning, as you probably noticed, but now we are in collision, now we are in stable beams, and the detectors are taking data continuously.
This is Director General with Director for Research Sergio Bertolucci, both from Japan.
We are very happy, and we congratulate everybody involved, from the machine to all the experiments. It is a fantastic moment for science, and Lynn was saying it's the end of a long road. I would say it's the beginning of a long, fantastic era of particle physics, of fundamental science. Thank you very much. We are all excited. Great.